balance the combustion reaction of benzene with oxygen. Here's our initial unbalanced equation. Let's start by counting the atoms on each side. For carbon, we have 6 carbons on the left from benzene, but only 1 carbon on the right from carbon dioxide. To balance this, we'll multiply CO2 by 6. Next, let's look at the hydrogen atoms. We have 6 hydrogens on the left from benzene, but only 2 hydrogens on the right from water. To balance this, we need 3 water molecules to get 6 hydrogens. Now for the oxygen atoms. On the right side, we have 12 oxygens from the 6 CO2 molecules plus 3 oxygens from the 3 water molecules, giving us 15 oxygen atoms total. On the left side, we need 15 oxygen atoms, which means we need 7.5 O2 molecules. To eliminate the fraction, we'll multiply all coefficients by 2. This gives us our final balanced equation. 2 C6H6 plus 15 O2 yields 12 CO2 plus 6H2O. Let's verify our balanced equation by counting atoms on both sides. For carbon, we have 12 atoms on each side. For hydrogen, we have 12 atoms on each side. And for oxygen, we have 30 atoms on each side. And there we have it. We've successfully balanced the combustion reaction of benzene. Remember, a balanced equation must have the same number of atoms of each element on both sides of the arrow.